Our next speaker is Whitney Lee, and she is going to come talk to us about who should be using Kubernetes. And the answer is not everybody, but let's find out what Whitney says.
Thank you, friends. I really loved the conversation before we got started here because I'm relatively new to Kubernetes, and part of what this talk, I think, is oversimplifying some of the aspects, but in a way that I needed to do so that I could kind of understand what it is, at least this aspect of it. So, who should use Kubernetes? The idea for this talk started with a question that my developer friend asked me, who is Kubernetes for? And I was surprised to realize I didn't know. Like, I knew Kubernetes is great to optimize costs and streamline operations for enterprise organizations, and I knew it's probably overkill for someone who's like building an app in their spare time, but I didn't know, like, what about in between, the huge range in between. So at what point do the benefits of Kubernetes outweigh the operational complexity? And what factors might an organization consider when deciding whether to adopt Kubernetes? So my name is Whitney Lee, and among other things, I host a show on Tanzu.tv called Enlightening. I'm a developer advocate at VMware Tanzu, and each week a guest comes onto my show and teaches me a cloud-related concept or technology, and I draw out the information on my Lightboard as I learn. So similar to what Fatima and Daniel talked about earlier, like learning out loud, and I'm forced to prove that I understand what they're talking about because I have to document it live. So I ask tons of clarifying questions as we go, and it's a streaming show, so I have lots of wonderful questions from the chat. I know some of those friends are going to come be in the chat here now, so thank you to them. And anyway, my experience with my friend asking me who's Kubernetes for inspired me to make an enlightening episode called Who Should Use Kubernetes? So I invited my talented teammate Lee Capili on to be my guest and help answer the questions. So we had a super fun stream where we discussed Kubernetes, and we learned a lot from chat about their experiences, including a literal server fire. And the episode ended with Lee doing a cartwheel. So that's the starting off point for my talk today. So, who should use Kubernetes? But before we talk about who should use Kubernetes, let's discuss the what and the why. But before we do even that, the time here today is very limited, so I'm going to declare some topics off limits. First of all, we're not going to define Kubernetes as a container orchestration platform. Granted, that's an absolutely valid way to describe Kubernetes, but it's not how I'm going to be talking about it today. We're not going to talk about cost optimization. Cost optimization is a big benefit of Kubernetes, no doubt, but don't you dare mention it. Using Kubernetes will help make your applications fault tolerant, partly because it automatically restarts failing containers, but you're just going to have to trust me on this one because now's not the time to discuss it. Kubernetes scales applications based on resource utilization, but don't ask me anything about it. We're not going there. Here's a bunch of other topics that are just totally off limits. That is not the point of today's talk. Right now, I'm going to talk about an often overlooked benefit of Kubernetes, and arguably the most important one, the big idea. But before I do, what is Kubernetes besides a container orchestration platform? Kubernetes is software that knows how to run software. Kubernetes is software that knows how to run your containerized applications. Kubernetes is distributed, so it has one interface, yet it runs across multiple computers at once. And with Kubernetes, you can turn lots of computers into one cohesive idea. Kubernetes is also declarative. So you define your system's desired state, and Kubernetes works to bring that state into being. And doing so, Kubernetes stores your way of working. So let's say it again for those in the back. For the purposes of this talk, this is how I'm defining Kubernetes. Kubernetes is distributed, declarative software that knows how to run your software. So keeping this definition in mind, here it is, the big idea, the often overlooked benefit of Kubernetes and one of the most important benefits. Kubernetes helps people work well together. Kubernetes provides a consistent, repeatable, cloud-agnostic way to define the building blocks of your system. Kubernetes creates a clear separation of concerns. People who use Kubernetes can understand how the parts of the system that they touch relate to other teams and to the system as a whole. And Kubernetes' standardized way of working creates a vibrant ecosystem of tools and best practices across organizations. So I've been going on about declarative, But to help understand what problem a declarative way of working solves, let's talk about the opposite of declarative, imperative. So to illustrate imperative versus declarative paradigms, let's consider a scenario where you ask me how to get to the library. If I answer imperatively, I would give you a series of steps as an answer. Step 1, go west on Riverside. Proceed for 2 miles. Step 2, turn right on Congress. Proceed for 2 blocks. Step 3, turn left on 2nd Street, and the library will be on your left. That's actually how to get to the library from my house, by the way. This is all very sensible, but it's also highly dependent on circumstances. What if you go to lunch before you go to the library? Those directions are no good without the proper starting point. What if Congress Avenue is closed for construction today? You're left with no recourse. Now, if you ask me how to get to the library and I give you a declarative answer, I'd simply give you the address to the library and a map. It would be up to you to choose the best steps to take given your circumstances at that moment. Okay, Whitney, you've convinced me. I understand that imperative is inferior, but what does an imperative system look like in practice? So I'm going to answer that with one word: scripts. Imagine you're in charge of creating and maintaining environments that host applications. You need a consistent way to install apps and their dependencies on several different computers. Before Kubernetes, the answer for this problem was big, long bash scripts. Scripts to install operating systems, scripts to install applications and dependencies, scripts to configure the environment. If the server restarts, scripts are used to restart all the applications that should be running. More scripts are needed to make sure that everything restarted correctly. If a script gets changed, how do you reliably update that script across the entire estate? What happens when a vulnerability is discovered? What happens when web traffic grows and you need to scale up? One way to imagine how difficult and tedious it must be to be an operator of a system that's run imperatively is to imagine that you're in charge of making sure that 2 laptops are exactly the same. And you're also in charge of keeping them exactly the same indefinitely. Did you install and configure software on one? Do the same for a second. Did you change the permissions on the first laptop? Did you update which apps you want to be able to notify you and how? Make sure you're capturing all of that and making the adjustments on the second laptop too. So I get it. Kubernetes is awesome because it's declarative. But wait a minute. What does declarative mean? What does a declarative system like Kubernetes look like in practice? I mean, I understand that with Kubernetes, you define this desired state of your system, but what is being defined exactly? Defining this desired state of your system feels pretty broad. How is the desired state of your system being defined? Who's in charge of defining it? It seems like a tall order. The desired state in Kubernetes is defined using Kubernetes resource objects. Kubernetes resource objects are persistent entities in the Kubernetes system. Kubernetes uses these entities to represent the state of your cluster. A Kubernetes resource object is a record of intent. Once you create the object, the Kubernetes system will constantly work to ensure that that object exists. By creating an object, you're effectively telling the Kubernetes system what you want your cluster or its workloads to look like. This is how you define your cluster's desired state. So if you're a developer, you're likely interested in Kubernetes resource objects that most closely touch your running application. So here's a quick overview of some Kubernetes resource objects that are used to define how a containerized application is to be run, accessed, and configured by Kubernetes. So you can define how you want to do scaling, rolling updates, and rollbacks in a Kubernetes resource object called a deployment. Within a deployment, a replica set resource object is where you define how many instances of your applications you want to be running at any given time. A pod is the Kubernetes resource object that is the smallest unit of compute in Kubernetes, and a pod hosts your running application. But at this point, the running application isn't accessible. A service resource object provides one stable endpoint that you can use to access one or many pods that are running your application, but that only provides access from within your cluster. To access your application from outside your cluster, you need a Kubernetes resource object called an ingress. You can define configuration for your pods with a resource object called a config map, and define secrets for your pods with a Kubernetes resource object called a secret. Those are Kubernetes resource objects you're likely to encounter as a developer, but there are many more. I'm going to rattle off a pile of commonly used Kubernetes resource objects, but don't worry about remembering them. The point is to show examples of the many different aspects of your Kubernetes system that are defined using Kubernetes resource objects. Namespaces are used to provide isolation between different projects that are sharing the same Kubernetes cluster. Persistent volumes represent pieces of storage in the Kubernetes cluster. Limit ranges provide constraints to limit the resource consumption of pods or containers. Resource quotas provide constraints that limit the aggregate resource consumption of all the Kubernetes resource objects in a namespace. Network policies are the specifications of how groups of pods are allowed to communicate with each other and with other network endpoints. Roles contain permission roles, and role bindings grant permissions defined in a role to a certain set of users. Nodes are worker machines and Kubernetes. Computers, these can be virtual or physical. Service accounts provide an identity for processes that run in a pod. And there are lots of types of Kubernetes resource objects. There are over 50 in the most recent release of Kubernetes. And there are many, many more. Thousands when you consider objects that you can make with the other open source projects in the Kubernetes resource ecosystem. But I'll talk more about that later. Right now, the point is that Kubernetes provides a way to declaratively define a lot of different aspects of your applications and of your system. So remember the big idea? Kubernetes helps people work well together. Specifically, Kubernetes resource objects are integral in helping people work well together. But why is that? Kubernetes resource objects help to create a separation of concerns and also a standardized way of working among people and teams who do share concerns. Different people within an organization care about different Kubernetes resource objects. Also, there's some overlap, as you will see. A site reliability engineer is in charge of making sure that things are working for our end users. They care about Kubernetes resource objects such as network policies, roles and role bindings, namespaces, and horizontal pod autoscalers. An infrastructure engineer is responsible for provisioning hardware and installing Kubernetes. They care about Kubernetes resource objects such as network policies, nodes, and certificate signing requests. A database administrator cares about database instances, migrating data, expanding hard drives, and accessing data. They care about Kubernetes resource objects such as volumes, storage classes, persistent volumes, and persistent volume claims. A cybersecurity engineer cares about security policies, access and authorization, and providing identity to workloads. They care about Kubernetes resource objects such as pod security policies, service accounts, roles and role bindings, and ingresses. An application developer cares about all the resources that I mentioned earlier, Kubernetes resource objects that touch their running application, such as pods, deployments, services, and config maps. Before Kubernetes, developers used to just send the binary to operations. Developers now feel closer to production because they understand how it will behave. As a result, they naturally adapt their designs for production. But what about the complexity? Kubernetes is notoriously difficult to install and maintain. The complex details of installing and running Kubernetes are increasingly being abstracted away. Many cloud providers offer managed infrastructure, also known as infrastructure as a service. With managed infrastructure, the cloud provider is responsible for servers, storage, and networking, while you manage layers on top of that, such as running a Kubernetes cluster. Or if that is too much work for you, there's also platform as a service. Platform as a service is Kubernetes itself as a managed service. These days, you can set up an initial cluster with a cloud provider in just a few minutes. With managed Kubernetes, your cloud provider is responsible for the Kubernetes control plane, as well as the server, storage, and networking that is provided with infrastructure as a service. It's true. I won't deny it. Kubernetes is complex. It may be hard to set all of this up, but it's worth asking yourself, what am I doing right now in my current system? Is setting up and using Kubernetes more complex than that? Kubernetes also has a vibrant ecosystem of tools and add-ons in the form of other open source software. There are tools that can be added to your cluster that help you do things like extract away complexity, or add observability, or add additional security, or tools that can supercharge your storage or your messaging or your databases. You can add additional software to improve the areas of Kubernetes that are important to your particular business. All of these tools are built upon the Kubernetes resource model that we talked about earlier. These tools work by each creating their own Kubernetes resource objects. Kubernetes is becoming mature, and best practices are emerging for common problems and issues. For example, use a software called Valero for making backups of your Kubernetes clusters. You don't need to worry about how this is done. The open source communities have figured it out. Or tools like Crossplane that leverage the Kubernetes resource model to enable you to define and spin up physical infrastructure across cloud providers in a Kubernetes way. Kubernetes helps people work well together because Kubernetes provides consistent, repeatable, cloud-agnostic way to define the building blocks of your system. Kubernetes creates clear separations of concerns. People who use Kubernetes can understand how the parts of their system that they touch relate to other teams and to the system as a whole. And Kubernetes' standardized way of working creates a vibrant ecosystem of tools and best practices across organizations. Okay, that all makes a ton of sense. But I still have another question, and this one is important. Who should use Kubernetes? And the answer is, perhaps you should. Let's go over some common pain points that Kubernetes helps to solve. Are you having issues because there's a mismatch between your production and development environments? If so, perhaps you should use Kubernetes. Developers can use Kubernetes in their dev environment, and in doing so, they'll have a better understanding of how the production environment will work. Are you suffering from not having a standardized way to communicate across teams, resulting in operational toil? If so, you should use Kubernetes. If you use Kubernetes, no matter in which language an application is written, it's configured and run using the same mechanisms. For example, both developers and operations teams use a config map object to set and tune an application storage or configuration. Is your infrastructure complex and difficult to manage? If so, you should use Kubernetes. The Kubernetes ecosystem has many tools to help with infrastructure standardization, tools that codify and version your infrastructure, for example, Argo CD and Flux CD. When your application needs to scale, is the process slow, complex, and risky? If so, you should use Kubernetes. Kubernetes helps to automate scaling using resource objects such as the horizontal pod autoscaler. An open source software called Knative further improves this process. Do you feel locked into your current cloud provider because it would be too complex to move? If so, you should use Kubernetes. To make your system cloud agnostic, you can rely on the Kubernetes API instead of using cloud provider tools. Does your company's operational knowledge exist only in people's minds? If so, you should use Kubernetes. The Kubernetes resource model helps you to define your operations in a concrete and standard language. It is a common practice to store and version this knowledge in Git. Formalize that knowledge and keep track of it. In conclusion, an often overlooked and very important benefit of Kubernetes is that Kubernetes helps people work well together. And for that reason, any growing organization should consider incorporating Kubernetes into their operational model. This is the end. Thank you so, so much for your valuable time and attention. I appreciate everyone. Yeah.
Right. Thank you so much. That was great. And I think we all enjoyed your slides. So if you were just listening, you should go back and look at the slides because they were amazing and hand-drawn. It's very charming.
Thanks.
We had the most trollish audience question ever. How do you pronounce that word? You know, the word that ends in CTL.
What do I say? Now that I'm on the spot, I say cute cuddle is what I say, but I don't see how I'm an authority at all.
Well, I think it's one of those like Coke or Pepsi questions. There isn't a right answer. It's just an opinion.
Well, I just became best friends with 50% of the audience and worst enemies with the other 50%.
Exactly. It's very divisive. So when you're thinking about who should use Kubernetes and as a way to help people work together, how much time would you say it takes to get useful with it? Like, how much lift is it?
I know this room is filled with people who are way farther along in their Kubernetes journeys than me. So if anyone else can chime in on this, I think my personal journey is that I started learning Kubernetes very recently. So, and this is my way of putting it together. So I haven't within an organization tried to implement Kubernetes to understand. Some of this talk is me even untangling what problem is Kubernetes solving? What did the world look like? Because since I came into tech in 2019, I'm already coming into a world where cloud technology is already pretty far along and Kubernetes is starting to be widely adopted. So part of it is me trying to untangle what was it like before Kubernetes? Yeah.
That's quite fair. I mean, at the same time, there's an aspect of it where asking questions of how all the resources work makes sense, because I've worked with various organizations where they just deploy Kubernetes and all of a sudden it's how does this daemon set work? Or we didn't even know we had to set up replica rules or making sure things auto scale and things like it. So everyone kind of goes on a Kubernetes journey in its own little way. That's always really interesting.
Yeah, it's fascinating to me. If anyone tells you they're an expert in Kubernetes, they're a liar.
Yeah. Great.
Oh, so apparently our guests have thoughts about that. Yeah. This is how y'all wake up, just talk about Kubernetes. That's what it took.
They just wake up very sassy about Kubernetes, and they go through their whole day just it's a namespace. Move on. And
maybe you don't have to be so angry about it if you recognize that you don't have to know all of it. You know your piece, and you know what piece other people are supposed to know. Yeah. Can I get a photo of me matching my...
Yes, definitely. I look back at a few years ago when I was doing Kubernetes one-on-one workshops where we were grabbing servers and rolling out manually rolling out Kubernetes. This is before cloud providers started doing their managed Kubernetes. And I look back at that at what I was teaching and where I'm at in my journey and how much knowledge I've gotten, and I'm I don't know shit, just straight up. And if anything, the last 3 months, taught me that when I joined the Kubernetes release team for 1.25 with our other MC and speaker, Kat Cosgrove. And it was oh, there's a lot of moving pieces of this entire open source project. And it's okay to be like Whitney said, I don't have to know. I don't know.
I think that it needs to be mandatory. Any Kubernetes learner resource, it needs to have in big red letters at the top of the page. You're not meant to know everything about Kubernetes. If I felt so overwhelmed trying to learn it because I felt like I only would know it if I understood all of this stuff. You know what I mean? So that's the message I would like to spread. Yeah.
I think that's a great message, and I think that it's really important for us to say the process of learning is worth sharing and worth talking about, and shouldn't be embarrassing.
So the folks should revisit Fatima and Daniel's talks, and then Brooke's talk.
All of them. You should just go rewatch the whole
planning
conference.
Talks that happened yesterday. It's definitely all coming together.
Yes. All right. Well, thank you so much. That was great.
Thank you. This is super fun.